Hi everyone, we're Team 5, we're Ecofolio, the Sustainability Social Network. So the problem that we wanted to address was a lack of actionable recommendations for individuals to reduce individual carbon emissions. Now we found that on a corporation level, there are many incentive structures in place already, such as a carbon tax. However, on an individual level, we found both a lack of education and a lack of motivation. Now this is a pressing issue because, as you can see from these two graphs, carbon emissions are projected to increase exponentially over the upcoming years. However, we wanted to address this problem by creating a web app with 3 objectives. The first objective is to create research-backed personalized recommendations. The second objective is to create a carbon footprint calculator and rating system. And lastly, we wanted to implement a friending feature to incentivize, to leverage social norming. Now, to create this web app, we had several specs, as you can see here. The first spec is that you can create a cryptographically secure account, and from there you can take our environmental survey, and from there you'll get 3 things. You'll get a carbon footprint score, rating, and also specific personalized recommendations. Afterwards, you can check across who your friends got, and then lastly, we've also implemented email reminders, so that way you can keep coming back and updating your score. There were some constraints that we faced when we were trying to implement these specs, however, namely the trade-off between survey specificity and ease of use, and also the limited AWS resources, specifically the limited server space and database storage. However, we worked around these constraints and are now at our final iteration of the web app. So as you can see from this demo here, you can create your account with an email and password, and then you can start adding your friends by their username. So for example, Tommy and Kevin. From here on out, you can take the environmental survey either in its entirety or in parts. Here we're taking it in its entirety first off. There are 4 parts. There's transportation, home, purchasing and food, and also work. For reference, the entire survey takes about 4 to 5 minutes. And then once you're done with the survey, you should get to this page right here, where you can see your carbon footprint score, your rating, and your personalized recommendations. Now, the key feature here is the personalized recommendations. So for example, if you look at the home section, it tells you that if you reduce your shower time to 25 minutes, then you'll save a little less than 4,000 gallons of water per year. Now let's say I come back in a week and I forgot my recommendations. Well, you can always log back in and then click on the View Recommendations tab. And then let's say you finished 3 out of the following recommendations that we provided for you. If you take the survey again, you can always click those so that way we can keep track of your carbon emissions. Once you get to that point, you can choose to take the survey again in its entirety or in its part. Here we just did the home section just for the sake of time. And here you can see that we provide the recommendations for that specific section. However, before we got to this final iteration of our project, we were considering several alternative designs. Specifically, we were considering gamification aspects in both the information delivery system as well as the incentive system. However, we chose to opt out of these instead and went with a customized recommendation system as well as social norming for both of these respectively.
Next, I'll talk about the process that went into developing the app. This slide here shows the solution components and our technical development of our solution. The main components here are the user survey input, our recommendation algorithm, and our recommendation output. And the main technical components behind the recommendation algorithm are our AWS Elastic Beanstalk application and the DynamoDB database. This next flowchart shows the user flow of our app, which begins when the user creates a unique and case-sensitive account on the app, and then can choose to take either the full survey or the survey in parts to receive a carbon footprint score and a rating. The user then receives recommendations and can add other users as friends to view their carbon footprint score and rating. Users can also receive bi-weekly emails to log back into the app. In terms of the survey development, the biggest challenge here was determining what kind of information to ask. We broke the survey down into 4 sections listed below there. The survey can choose which of these categories to take and will only receive recommendations for the categories that they complete. Next is the development of our recommendation algorithm. This was a very heavily research-backed algorithm that required synthesizing information from over 30 sources, including the ones you see listed there. We condensed this research into an algorithm, and the result is our algorithm that generates customized recommendations based on your specific survey input. In terms of measuring user progress, we achieved this through our Carbon Calculator API. First, in terms of calculating the carbon footprint itself, we did this through an API call to the EPA, and the input was data collected from the user survey. To calculate the carbon footprint rating, we looked at state-level data for the average carbon footprint per capita and transformed this into a normal distribution. In terms of updating the carbon footprint, we query the users every 2 weeks to track the completion of the recommendation. Measuring the actual impact of taking the recommendation is done through looking at the equivalent carbon emission of a recommendation. First, we express the environmental savings in terms of units specific to that recommendation. To measure the impact of taking the recommendation, we convert these units into equivalent carbon emissions. And if the user actually takes the recommendation, that's shown in that equation below, where CNU is the user's new carbon footprint, CO is the old carbon footprint, and each of those sums represents an equivalent conversion factor multiplied by the delta and the change in the user's input.
Okay, so now I'm going to talk about some potential ethical issues related to our project. Okay, so the first is we're asking users to sign up and create an account on our website, so we sort of have an obligation to them to create really secure accounts. And we solved this by implementing a really cryptographically secure login algorithm, where we actually never store a user's password in our database. We store the user's password, the hash of the user's password in a random salt. So that makes it very hard to compromise the account. And the next issue is we're also asking users for information about their lifestyle, and they might not want us to really be able to look at the information, or they might not want anyone outside of the organization in the case of an attack to be able to see it. So we need to protect their private information, and our solution was to actually not store any of their survey inputs. So let me explain. What happens is the user will submit the survey, and on the post request that we receive, we will immediately compute their recommendations using our recommendation algorithm. And we only store the personalized recommendations, but after computing them, we do not store any of the survey inputs in our database. And since the recommendations are hard to reverse engineer, this really protects the input that they inputted.
Great, so diving a little bit into project management and how we actually got to this point. Basically the technology that we use throughout, for both the user accounts and the web application, were of course this hash that Tanvi talked a little bit about, and then a whole host of other tools and other techniques in order to actually build a web application. But we can dive a little bit more into this later if you're interested. The total project cost was just over $150, and this is to date, but some of the costs are kind of monthly recurring, so that's something that we'll continue to work with. And what we want to leave you with is the impact of our web application. We set our goal at 50 users and reducing the carbon emissions per user by 10 pounds per user per month. But as you can see here in the green bars, what we've seen is a huge increase in that goal, 162 and 168% respectively, and in aggregate have reduced just under 1,400 pounds of carbon by delivering 316 recommendations to our users. But with that, thank you so much for your time, and we're happy to talk.